Hey there everyone, I am Ridhima from IIT Classes and welcome to the part 4 of solving our IIT JAM Maths 2023 question paper. So the question in front of you here is given. The value of the limit n tends to infinity for the following expansion is equal to how much, right? So here let us say this is un is equals un as the expansion, un is equals to 1 plus 1 by 2 to the power n plus 1 by 3 to the power n plus up to 1 by 2023 to the power n. Okay. Now we know that limit n tends to infinity un by un plus 1 is equals to limit n tends to infinity un to the power 1 by n. We know, we are aware of this formula. Now from this, if we write down un by un, this is un plus 1 by un, right? Un plus 1 by un. So this can be written as follows, that is 1 plus 1 by 2 to the power n plus 1 plus 1 by 3 to the power n plus 1 plus up to 1 by 2023 to the power n plus 1 whole divided by 1 plus 1 by 2n plus 1 by 3 to the power n plus up to plus 1 by 2023 to the power n. Now here if we put the limit n tends to infinity, then of course you can understand that this term and this part is 0, so we have the answer 1. Now according to this formula, right, we can write down limit of n tends to infinity un plus 1 is actually is equals to limit of n tends to infinity un to the power 1 by n, which is here is equals to limit n tends to infinity 1 to the power 1 by n, and of course the answer is 1. So the next question here is basically we have to find out the sum of the given series, okay? Now, so the series, let us denote it with un is equals to summation n is equals to, okay, let us say un is just this one, the expansion is given by un, that is equals to 2n plus 1 by n square plus 1 into n square plus 2n plus 2. Now this can be written as n square plus 2n plus 2 minus n square plus 1 divided by multiplication, that is n square plus 1 into n square plus 2n plus 2. Okay. Now here, so why I have written it, you can easily see this n square minus n square gets cancelled, 2 minus 1 is 1, and you have 2n. So basically if we simplify this, we will get 2n plus 1. So instead of writing 2n plus 1, I have written it in this format. Okay. Now, so if you simplify this, that is n square plus 2n plus 2 divided by n square plus 2n plus 2 into n square plus 1. So you can see that this and this term gets cancelled. Minus n square plus 1 whole divided by n square plus 1 into n square plus 2n plus 2. Again this gets cancelled. So ultimately we have un is equals to 1 by n square plus 1 minus 1 by n square plus 2n plus 2. Now in this, so what we have to find is the summation of the series. That is, we have to find summation n is equals to, let's see, the limit 1 to infinity. Un, right? So let's say when n is equals to 1, u1 is equals to 1 by n square plus 1, this is 1 plus 1, 2, minus 1 by, so this is 1 plus 2, 3 plus 2, 5, When n is equals to 2, u2 is equals to 1 by 5 minus, so this is 4 plus 2, 6 plus, this is 2 square 4, 4, 8 plus 2, 10. So this is 1 by 10. When n is equals to 3, we have u3 is equals to 1 by 9 plus 1, 10 minus 9 plus 6, 15 plus 2, 17, 1 by 17, and so on, right, till we get un, and we know un is equals to what? Un is equals to 1 by n square plus 1 minus 1 by, let's check again, n square plus 2n plus 2. So that is n square plus 2n plus 2. So summation here, if we take the sum of this, this is very clear that from the second term onwards, it is getting cancelled, right? This gets cancelled, this cancelled. So obviously this will get cancelled because I will have here 1 by 17. So in this way, before this, the second term here, whatever it will be, that and this term will be cancelled, right? So if I take summation of un, so I will actually have half minus this term. And now when I use the limits, the limit is from n is equals to 1 to infinity. That is when as n tends to infinity, here summation un will tend to half minus 0 is equals to half. So that means the answer to this is half. The next question in front of you is given a function of xy as the exponential function, and a determinant, that is an, that is this is an determinant which is given. So actually so here we have to find out the determinant at points. The points given are, actually it's not given, so the points that according to the question paper given is sine of n and cos of n, and you have to find out limit n tends to infinity a of n. So first we have to calculate this at this point, and then we have to put n tends to infinity limit in this an and solve the answer. Okay, so before that, as we can see, the matrix is basically the second order derivative of the given function. So let us first find out the following. So basically this is our f. We have to find out fxs, fxy, f of yx, and f of yy. Correct? Xx, xy, yx, xy. So let us start. First, let us write down the function that is given in the question. F of x, y is equals to e to the power x square plus y square. Right? So let us first find out how much is fx. Fx is, of course, e to the power x square plus y square into 2x. F of y is equals to e to the power x square plus y square into 2y. Now f of xx is equals to fxx. Let us find out fxx. Fxx is equals to, so this is 2x. Now we take the derivative, that is e to the power x square plus y square, and this becomes 2x plus 2 e to the power x square plus y square, because this x is 1. So this becomes basically 4x square e to the power x square plus y square plus 2 e to the power x square plus y square. Now if we take derivative of fx with respect to y, then here we have 2x e to the power x square plus y square 2y. That is 4x e to the power x square plus y square. So let us highlight the answers, right? So this is, sorry, this we don't have to highlight. We only need the second order derivative for our matrix. So this is the first one, that is fxx. This is the second one, that is fxy. Now similarly we are going to find out fyy. So fyy will be what? How much? See, fy is, this is fy. So let us say first we are taking the derivative of e. So 2y remains as it is, and this is e to the power x square plus y square into 2y, plus now we have y is 1, so that is only 2 e to the power x square plus y square. So that is in a much simplified way we can write down 4 y square e to the power x square plus y square plus 2 x square e to the power x square plus y square. So let us highlight this as another element. And lastly we have fy of x. So now the fx to be fy is to be taken derivative with respect to x. So if we do that here, so this will remain, and here we have e and 2x. So let's write down, that is 2y e to the power x square plus y. It is 2y e to the power x square plus y square into 2x. That is 4xy e to the power x square plus y square, right? So let us highlight. So what are the elements that we have? So if we scroll up and check, we have we also have a y here which I missed. Yes, so this is 1, this is 2, this is 3, and this is 4. Now let us write down our matrix, right? So we are given an is equals to, the matrix is basically fxx, fxy, fyx, and fyy. Let us check again still. Yes, fxx, xy, yx, yy. So now we are going to put the 4 values that we have calculated, and then let's find out the determinant of an. So now let us write down the values here. So fxx is here. Now this we can take common right here. That is, we can take 2ex square y square as common. This can be taken as common. So the value will be basically 2 of e to the power x square plus y square. We can take it as common, and in bracket we will have 2x square plus 1. So let us write it down here. That is 2 e to the power x square plus y square into 2 of x square plus 1. Fxy, let's have a look at fxy. Right. Fxy is 4 xy e of x square plus y square, and if you look at it, fxy and fyx both are same, so we can just put the values here. So this is 4x into y e to the power x square plus y square, and fy is also same, that is 4xy e to the power x square plus y square. And fyy, let's check fyy. Here again, here also we can take common the terms like 2 e to the power x square plus y square, and in brackets we have 2y square plus 1. So the last element is 2 e to the power x square plus y square into 2y square plus 1. Okay, now in the question it is given that we have to find out the value of the determinant of this matrix at points sin n and cos n, right? So that means x is equals to sin n and y is equals to cos n. Now from the formula, that is x square plus y square, that is sin square plus cos square is equals to 1. So this, and this, all of this can be written as 1. So let us write down the matrix now in a simplified manner, that is 2e 2x square plus 1 into 4xye into 4xye into 2e 2y square plus 1. Now, so the determinant, let us operate the determinant. So we can take common from here, right? We can take 2 and e as common. So the first row becomes 2x square plus 1, 2xy. And from here also we can take 2e as common. So 2e into 2e, and here we have 2xy into 2y square plus 1. Now here, so this can be written as 4e square, right? So an is equals to 4e square of the following determinant, that is 2x square plus 1, 2xy, 2xy, and 2y square plus 1. Is equals to 4e square into, so that is 2x square into, so we have to actually multiply these two terms. So we here get 2x square into 2y square, so that is 4x square y square. 2x square into 1 is equals to 2x square. And 1 into 2y square is equals to 2y square. And 1 into 1, so that is plus 1. Correct? And here we have minus 4x square y square. Now these two terms get cancelled, plus minus, so let us cancel it. Now here we have is equals to 4e square. Let us take 2 as common, so that is x square plus y square plus 1. Now this x square plus y square is, x is our sin n and y is our cos n. So sin n square plus cos n square is 1. We know sin square n plus cos square n is equals to 1. So this is x, this is y. So what we have here, an is equals to 4e square into 2 plus 1, that is 12e square, and that is our answer.